I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and taking keen interest. Lately, we have received some requests where the students want to understand solutions for rational equations and especially what are extraneous roots. Based on their request, I have taken 6 examples and I hope these examples will help them to understand the complete concept. Some of these examples have solutions, some do not. Some have extraneous roots, some do not. So it's a kind of a combination, a mix. We'll also understand different methods of solving rational equations. I'd like you to make a note of these equations, try them out, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. We help you to reach the goal by following this success path.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. Now let's look into these solutions one by one. As you can see, the first equation is kind of a proportion. Second is also like that. Third and fourth are slightly different, where we have 3 different terms. And then we'll end up with 2 more equations which will help you to practice the solution. Whenever you look at the rational equation, what you need to do is to check for restrictions. So that is kind of important. So even before beginning, let's call for restrictions. Can you identify restrictions? If you can, you will know which roots are extraneous. That's the key. So in the very first equation, denominator cannot be 0. So therefore, x is not equal to minus 2 by 3 or even 0. In the second equation, x should not be equal to minus 3 or minus 5. In the third equation, x is not equal to minus 1 and plus 1. In the fourth equation, x is not equal to 2. Right? And in the fifth equation, x is not equal to 1, right? And here, x is not equal to, again, 1 and plus minus 1, right? So, even minus 1. Do you see that? Now, the idea is that when you solve, and if you get one of the answers, which is out of the restrictions, then that will correspond to the extraneous roots. So, I hope this concept is clear, right? Now we'll take care of this while solving the equations. But it's good to begin with the knowledge of what extraneous roots could be. Okay, so let's get to the solution for question number 1. 3 over 3x plus 2 equals to 6 over 5x. Now when you are given a rational equation, you could solve it using 2 methods commonly used. One method, I say cross multiplication. And the second is getting rid of denominator by taking lowest common denominator, right? And then the idea is to get rid of denominator. Now that denominator really causes a lot of problems. Therefore, I have written it in capitals. Okay, so to begin with, whenever you need to solve a rational equation. Start with writing restrictions. We know that 3x plus 2 should not be equal to 0. That means 3x is not equal to minus 2 or x is not equal to minus 2. And also we have 5x which is not equal to 0. That means x is not equal to 0. So in this case, we have two restrictions. One, x is not equal to minus 2. The other one, x is not equal to 0. So let's write down our restrictions, and that is x is not equal to minus 2 and 0. In case you get that as your solution, it will be an extraneous rule. You get an idea. Now, out of these two approaches, whenever we have kind of proportions, we use cross multiplication. So in this case, we are going to use cross multiplication. What does that really mean? It means that we are going to multiply 5x with 3, right? And 3x plus 2 with 6. That is what we are going to do, right? So we get what? So look here, we get 3 times 5x equals to 6 times 3x plus 2. That is cross multiplication. Do you see that? So we applied the strategy 1, which is cross multiplication. Absolutely clear? Now let's expand and simplify. So 3 times 5x and 6, you could also simplify this straight away. You could write this as 5x equals to 2 times 3x plus 2. No harm, right? So what did we do here? We just divided by 3 on both the sides rather than opening the brackets and working with bigger numbers. So at this stage, what we have done is we prefer to work with smaller numbers, right? So simplify. Smaller numbers. That's the key, right? So while we are solving, we are also understanding the best practices. Okay, let's take it on this side and continue our solution. 5x is equal to what? 5x is equal to 2 times 3x, which is 6x, plus 2 times 2, which is 4. Now, you should bring variables to one side, constants to the other side. Let me take 5x to the right, 4 to the left. So we get minus 4 equals to 6x minus 5x, and minus 4 equals to x, and that becomes our solution. So the solution in this case is x is equal to 4. Perfect. Now you can see x equals to 4 is not one of the restrictions, and therefore it is not an extraneous root. Now it's a good idea to check your result, right? So let's do the checking for the result in the first case. So in the first case, we identified that the restrictions are not minus 2 by 3 and 0. Correct? And we found that x is equal to minus 4 is our solution, correct? Minus 4. Okay. So let's check if that is true. So let's substitute to check. So we have two sides to this. One side, we are calling this as left hand side, and the other as the right hand side. So let's substitute x equals to minus 4 in each. So if I substitute on the left hand side, we get 3 over 3 times minus 4 plus 2, which is 3 over minus 12 plus 2, and that is 3 over minus 10, right? On the right hand side, if I substitute, I get 6 over 5 times minus 4, which is 6 over minus 20, which can be simplified as 3 over minus 10. So on both the sides, as you can see, we get minus 3 by 10, correct? So which are equal, and therefore it is the correct solution. Is that clear to you? So it's a good idea to check your solutions also, just as we did for the first one. Now let's look into the second question and its solution. Okay, so what should we do? Well, in this case, because it is like a proportion, the strategy is cross multiplication. Also, we have to begin with writing restrictions. Denominator cannot be zeros. Therefore, x is not equal to minus 3 and x is not equal to minus 5. Perfect. Now let's cross multiply to solve. So we get x minus 2 times x plus 5 equals to x minus 4 times x plus 3. Let's expand. We get x squared plus 5x minus 2x minus 10 equals to x squared plus 3x minus 4x minus 12. Just apply the distributive property, right? It's clear. We multiplied with x both the terms, right? So that gave us the first two terms, and then we multiplied with minus 2 and gave us the next two terms. Repeat this process. Now, let us combine the like terms. So we get x squared plus 5x minus 2x gives us plus 3x, and we have minus 10 here equals to x squared minus x minus 12. Correct? Now we can bring all the terms together and solve. You see x squared equals to x squared minus this, so you can cancel x squares from both the sides, right? And then bring the terms together. So I'll prefer to bring the variables on the left hand side. So I'll write this as plus x and the constants to the right hand side. So which gives me 4x equals to minus 2 plus 10 as minus 2, right? Minus 12 plus 10. And that gives me the solution that x is equals to minus 2 over 4, which is minus half, correct? So we have the solution of this equation, x equals to minus half. Is that clear to you? Now this is not one of the restrictions, and therefore here also we do have a solution, which is x equals to minus half. With these two examples, we got the strategies of cross multiplication, right? Now with the next example, where we have three terms, what are we going to do? Well, let me write down that x is not equal to plus minus 1, as that is a restriction. Denominator cannot be 0. But now, let me find the lowest common denominator. So in this case, what is the lowest common denominator? So the lowest common denominator is the product of x plus 1 with x minus 1, right? So that is it. Some of you know that this can be written as x squared minus 1. You can expand and simplify, correct? Perfect. So what we are going to do is multiply each term on both the sides, that is, by LCD, lowest common denominator, which in this case is that. Perfect. So let's do that. So when you do that, you get 2x times x minus 1 plus 4 times x plus 1, correct? Because x minus 1 in the denominator cancels with the numerator x minus 1, equals to 2 times x plus 1 times x minus 1, correct? Well, some of you can also write this as 2 times x squared minus 1, because that is what this is equal to. Now let us expand. So when you expand, you get 2x times x as 2x squared minus 2x plus 4x plus 4 equals to, let's open this, we get 2x squared minus 2, right? You can bring all the x's on the left side and the constants on the other side. So we get 2x squared minus 2x plus 4x. Let's combine them, right? Okay, so if I combine them, I get plus 2x, and here we have plus 4, bringing minus 2x square plus 2 equals to 0. And now 2x square minus 2x square is 0, and so we have 2x, and here we have 4 plus 2, which is 6 equals to 0. Now we can solve this. 2x equals to minus 6, and that implies that x is equals to minus 6 by 2, which is minus 3 by 2. Okay? So 3 by 2 is not a restriction, and that becomes a solution, right? So in this case also we have a solution which is x equals to minus 3 by 2. Perfect? Okay, so we have a solution for this. Now let's look into question number 4. So this time we have x over x minus 2 plus 2 over 3 equals to 2 over x minus 2. Let us see how do we solve this particular question. Now, starting off, we have a restriction, x is not equal to 2, that will make the denominator 0. And then we have the lowest common denominator, which is also x minus 2 in this case. So multiply each term by x minus 2, so we get x plus 2 times, well 3 is also there in the denominator, so the lowest common denominator is 3 times x minus 2, right? So this gets multiplied by 3, and here it gets multiplied by 2 times x minus 2, and we have 2 times 3. Perfect? So let's bring all the terms with variable on the left side. First let's open this up, and what do we get, right? We get 6 here on the right hand side. 3x plus 2x is 5x. We'll take minus 4 to the right side. So we have 5x equals to 10, and x is equal to 10 by 5. So what do you get x as? Which is 2, correct? So in this case, we get our solution x equals to 2. Perfect. Now what do you notice? X equals to 2 is a restriction. So therefore, it is an extraneous root. And since it is an extraneous root, and that's the only one we have, so we have no solution to the equation. You get the idea. So I hope you understand. If you identify extraneous root right away, it becomes very easy to identify the extraneous root. I mean, when you identify the restrictions right away, it is very easy to find whether the solution is an extraneous root or not. Make sense? Perfect. So now let's get to the last question, which is x minus 5 over 1 minus x equals to 3 minus x over x minus 1. So I'd like you to check this out. Okay, let's begin with the restriction. X is not equal to 1, since that will make the denominator 0. So you can actually cross multiply, right, and then solve. I'd like you to actually pause the video at this stage, cross multiply, and then solve this equation. Perfect. So let's cross multiply. We get x minus 5 times x minus 1 equals to 3 minus x times 1 minus x. Okay, let me bring all the terms to the left hand side. I'm just using a different strategy. So we have x minus 5 times x minus 1, and bringing this here, I could write this as minus of x minus 1, right? 1 minus x. Okay, so let us first cross multiply and then simplify. So we have x minus 5 times x minus 1, which is 3 minus x times 1 minus x. Let us expand. We get x squared minus x minus 5x plus 5 equals to 3 minus 3x minus x plus x squared, right? Bring all the terms to the one side, let's say constants on the other. Okay, so we have x squared minus x minus 5x will give us minus 6x, right? And then bringing, okay, let me first simplify each side, right? So 3 minus 4x plus x squared, right? X squared will cancel. We have 6x and minus 4x. Let's bring them here, and 3 and 2 on the other side. Okay, so as you can see here, they cancel, right? We have minus 6x and minus 6x. Let's bring that 4x on this side plus 4x and 3 minus 5 on the other. So that gives us minus 2x equals 2. 3 minus 5 is minus 2, and that gives you the value of x as equal to minus 2 divided by minus 2, which is indeed 1. Now in this case also, you see that x is not equal to 1, right? Because that will make the denominator 0. But here we get x equals to 1 as the only solution. This has to be extraneous root, right? So since x equals to 1 is a restriction, we have an extraneous root. At x equals to 1. So there is no solution. You get the idea. So with cross multiplication, we saw that there is no solution. Okay, so what we see here is again, there is no solution. Here is the last question for us. We have 5 over 2x minus 2 equals to 15 over x squared minus 1. Now in this case, you can see the restrictions that 2x minus 2 should not be equal to 0. That means 2 common, x minus 1 not equal to 0. And that gives you x is not equal to 1, right? And the other one is x squared minus 1 not equal to 0, means x squared is not equal to 1. That means x is not equal to plus minus 1. And that means the restriction is that indeed x is not equal to plus minus 1, right? So these are the restrictions. Now, we could cross multiply and then solve. Perfect. So let's do it. So let's cross multiply. So we have 5 times x squared minus 1 equals to 15 times 2x minus 2. So when you open the bracket, you get 5x squared minus 5 equals to 30x minus 30. Let's bring all the terms together. Since it becomes a quadratic equation, we have 5x squared minus 30x minus 5 plus 30 equals to 0. So in this equation, let me rewrite this. By combining the constants, we have 5x squared minus 30x plus 25 equals to 0. Taking 5 common, I could always write this as x squared minus 6x plus 5, correct? Equals to 0. Now we can factor product being 5, sum being minus 6. So I could write this as x minus 5 times x minus 1 equals to 0. Is that correct? So we have now factored it. Since we have all this, what are the solutions? Well, the solution could be x equals to 5 or x equals to 1, correct? However, if you notice the restrictions, then x equals to 1 is extraneous root, right? So this is extraneous. So the only solution is x equals to 5, and therefore the solution is x equals to 5. So in this particular case, we got one solution and the other one was an extraneous root. You get the idea. So that is how we actually solve rational equations and look for the extraneous roots. Perfect. So now, let's summarize what we have learned. First thing to begin with is write down the restrictions, right? So x is not equals to minus 2 by 3 or 0, x not equal to minus 3 or minus 5, x not equal to plus 1 and minus 1, correct? X not equal to 2, x not equal to 1, x not equal to 1 and minus 1, correct? We did find that the first two equations have solutions. Here we said that there is no solution, right? So in question number 3, we found that the answer was minus 3 by 2. That's correct. Okay. So in 3 we had x a solution. In this particular case, we figured out that there is no solution, right? And here also no solution. In this case, we had one solution and one extraneous root. Perfect. So with that, we wind up on solving rational equations and understanding which roots are extraneous. Basically, the roots corresponding to the restrictions will be extraneous. You get the idea. So that is important to understand. So I hope with this you get all the concepts. Feel free to write your comment, share your views. If you like and subscribe to my videos, that would be great. Thanks for your time and all the best.